Hello, good day and welcome to my channel. In this tutorial video, we'll be looking at how to conduct panel cross-section dependence test. Specifically, we would like to know why we need to conduct the test and how to correct the problem if it exists in a panel regression model. Okay, conceptually, cross-sectional dependence relates to the interconnectedness among cross-section in a panel setting. We want to know how events or activity in one cross-section influences event or activity in the other cross-section in the panel setting. Like for instance, we have this ongoing Russia-Ukraine war. Okay, now we want to know how. We want to know if this war has influence on other countries of the world. Okay, you will believe with me that with technology, the degree of interconnectedness among the world is rising. Okay, so cross-sectional dependence is something that is natural in the 21st century because of technology and so on. Now, why do we need to conduct a cross-sectional dependence test? Okay, cross-sectional dependence test is important because it helps identify, it helps us validate whether or not the estimator is efficient and whether the test statistics are valid. If there is the presence of cross-sectional dependence in a panel regression model, then it means that the estimator are inefficient and the test statistics are invalid. It therefore suffices to say that with cross-sectional dependence present in a panel regression, then the panel regression model is a biased estimate. Okay, so one of the important conditions, for an unbiased regression, an unbiased and efficient panel regression model is that we have a cross-sectional independence in the panel regression model. So if it exists, then it means that we need to correct for it to have an unbiased, efficient, and valid test statistics. Now let's operationalize what we've been talking about. How do we conduct this test? All right, here in my EViews folder, I have three variables for the purpose of this tutorial video that I would use. I will use invest, fixed capital, and share. I will take invest as the dependent variable and fixed capital and share as the independent variable. Okay, so I'm going to click on invest and hold down control and click on other variables in the model. So I would like to adopt. Then I'll right click. I'll open as equation. Yes. Okay, now because I brought in the variable into Excel as a panel setting, this drop down menu is automatically configured, to do panel estimation. All right, so we have least square. This least square is panel least square and not just the ordinary least square, because of the setting of the data in here. So we click on OK. Now when you click on OK, you see panel least square. This is the result. Now, cross-section dependence test is a post-estimation test. It's a test you conduct after your panel regression has been estimated. All right. How do we conduct it? You come to View, then you come to Residual Diagnostics, and then you see cross-section dependence test. You click on it. Now we have the test result here. The null hypothesis is that no cross-section dependence in the residual. Now, there are three tests: statistics, identify. Here we have the Pruchbergen, we have the Pecheran scale, and we have the Pecheran CD. Now, by virtue of the probability statistics here, we are to reject the null hypothesis, because we reject null hypothesis when the probability value is less than or is less than or sometimes equal to 0.05. So in this case, we reject the null hypothesis. For us to accept the null hypothesis, we need 0.05 upward, or greater than 0.05. So invariably, we are saying that we have cross-section dependence in the model. All right. The implication on this is that we cannot rely on the estimated regression. The estimators are inefficient and the test statistics are invalid. Okay, for us to correct for this situation, that we have various ways of correcting for this, but I'm going to deal with one. All right, and that is by using the generalized least square method, usually through the cross-section similar related regression. Now let's go back to the estimate. We say the estimate here, right? The drop down menu here, you will see panel option. You click on the panel option and then you see the GLS weight. All right, you come here and we'll click cross section SUR. Okay, and then we'll click on OK. We'll click on OK. We have a weighted result, weighted least square result presented to us. On this result now, we want to test whether or not the cross-section dependence is still present. Okay, how do we test? We click on View, come back to residual diagnostics, and we click on cross-section dependence. Voila! We see you would realize that 2 statistics of 3 statistics are telling us to accept null hypothesis. Okay, Pesheran, Buchbergen, Pesheran CD. They are probability value greater than 0.05. So they are telling us yes, we should accept that there is no cross-section dependence in the model. Okay, so that is cross-section dependence, and that is one of the things we should look out for when we are doing a panel regression analysis. Okay, it has the implication of making our estimator inefficient and our test statistics invalid, with consequently result to result to a biased estimate. All right, thank you. That is all we have on cross-section dependence test. If you are joining this channel for the first time, or you have been to this channel before but you have not subscribed, kindly subscribe if you enjoy the content. Thank you. See you in the next video.